Hi, my name is James Lee, and I'm a professional services engineer at Puppet by Perforce. I wanted to take a minute to share an example of how I used Puppet in a personal project to solve a really hard problem. Namely, how can I deploy a custom Python program with lots of dependencies to a wide variety of platforms without having to become a Python or packaging expert? You see, I've been experimenting with a number of single board computers like this Rock Pro 64 to build a mobile streaming server that I can use to stream from my GoPro to Twitch. My goal is to be able to migrate to a small, inexpensive computing platform like this Raspberry Pi 3. To make all this work, there's an open source program and library called OpenGoPro. This is a Python project that, among other things, lets me configure and view my GoPro live stream. Installing it, at least on the command line, is fairly straightforward. We use pip to say pip install OpenGoPro, and the package and all of its dependencies will be downloaded from the Python package repositories. Now, as I mentioned, I want to ensure that my deployments are consistent across different platforms. And so I want to use Puppet to manage this installation. Let's see what that would look like. So here I am on an Ubuntu 22.04 virtual machine, and I'm going to write a simple manifest that defines a package resource for our OpenGoPro package. It looks like this. Package, the name OpenGoPro, and we'll say we want to ensure that it is installed using the pip package provider. Okay. And we can evaluate that using Puppet apply. There, in just a few seconds, Puppet has used pip to install the OpenGoPro package for us. And we can confirm that by looking at the file system. If I list user local bin, now we see all of my GoPro commands, including, my GoPro live stream, my GoPro video, GoPro webcam, all of these commands that let me interact with my GoPro. However, Puppet kind of hid something from us here. Let's start from scratch and see what happens when we try running that installation command by hand. We see indeed that pip installed the package and all of the dependencies that we need, but we also see a warning that was hidden in our Puppet run output. The warning tells us that running pip as the root user can result in broken permissions and conflicting behavior with the system package manager. And this makes sense. A number of Python libraries are pre-installed by the operating system, and it varies by the operating system. Ubuntu is going to have a different way of managing Python packages than Red Hat. So using pip alongside the system package manager can result in undesirable behavior. We are recommended to use a virtual environment instead. So let's look at this link and see what it would take to deploy this software to a virtual environment. Okay, well, so there's some good documentation here for sure. And it looks like, we can install packages into our virtual environment using pip. But I gotta tell you, I'm not a Python expert. I don't work with this stuff every day, and honestly, I'm not really interested in becoming a Python expert. Not right now. I'm interested in live streaming. That's what I'm interested in. So how can I achieve this result using tools that I do know? Well, I know Puppet, so let's see how we can do this with Puppet. So I know from experience that I've never seen this Python virtual environment stuff in the core Puppet platform. But that doesn't mean Puppet can't do it. It just means we got to look towards the community. And it just so happens that we have that here at the Puppet Forge. So I went to the Puppet Forge and I searched for Python. So let's see what happens. All right, we get some results back. We get a number of results back. And this first one definitely catches my eye. It says here in the README that this module is for installing and managing Python, pip, virtual environments, and virtual hosts. Well, this sounds like exactly what I need. And it just so happens that it's also an approved module, which means that it meets Puppet standards for being well-written, reliable, and actively maintained. And that's no surprise coming from the Vox Pupply community development group. You'll see a number of modules written by this group, and they all tend to be of very high quality. So how can we get started with this module? Well, of course, the README gives us a hint. It tells us how we can configure and use this module through Hiera by expressing the virtual environments that we want, where we want them to be, and then the packages that we want to install in those virtual environments. We can also look at the reference tab here for a more complete description of all the classes and defined types delivered by this module. Notably, we see defined types for pip and py-env. These are the ones that I suspect we would want to use from within Puppet code itself. Let's try this module out and see how it works. So to start using this module, we just need to include this line in any of its dependencies into our Puppet file. So I'm going to copy this line. I'm going to head into VS Code, where I already have my control repo open. I'll open up my Puppet file. There are a number of other modules in here already, but we're going to add one for OpenGoPro. And it's going to look like this. OpenGoPro, yep. So we have our Python module. Do we need anything else? We need to look at the dependencies tab here. And we see that this module also requires standard lib and EPEL. Standard lib I already have for some other module in my Puppet file. So we're okay there. And EPEL, I happen to know, is for setting up the package repository for Enterprise Linux, which is not applicable here. I'm not using Enterprise Linux, so I'm going to skip this dependency. That's okay. I'll save this, and let's go ahead and commit this to a new branch. I'm going to make a new branch. I'm going to call it feature streaming. This is representing all of the features I need to do streaming. This branch. We'll see here on my source control pane that I can commit changes to my Puppet file, but let's develop a little more code first. Typically, I will start by writing a profile class and build up from there. So here under my profile module, I'm going to make a new manifest. We're going to call it OpenGoPro. class profile open GoPro. And inside this class, I'm going to define a couple of resources. From this Python module. Namely, I think I want to define my Python virtual environment and my pip package for inside that virtual environment. So I'm going to scroll down to the pyvenv section, and you see under this this reference section, we even have an example of how to use it. We have the defined type name there, the title, which represents the path that we want our environment made in, a number of other parameters that control the behavior of this type, including the source of our Python, whether we want it from a specific user or the system, the directory, the owner of that project, the group. A number of other parameters are here as well. I think we can keep it simple and just tell it where we want this virtual environment. So we'll say Python pyvenv. Let's install it to opt open GoPro. We want to ensure that it is present. Very nice. Next, we'll say that we want to install our OpenGoPro package into that virtual environment. We'll say Python pip OpenGoPro. And we'll say we want to ensure that it is present. Want to install it into our virtual environment. And the virtual environment is opt open GoPro. And yeah, that's it. So that's a pretty basic class, I think. Okay, so this gives us our profile class that represents the technology that we want to deploy to our node here. We now have to declare this profile class, and to do that, I need a role class. I'm going to open up my role module, and in the manifests folder, I'm going to make a new file, and we're going to call this, well, what is the role of this node and this node? Well, they're both streaming servers. Okay. There must be something more catchy than that. I thought we call it a stream box. This is my stream box. So make our role class here. Our class name needs to agree with our manifest name, and inside of this, like any other role class, all it does is declare profiles. So what does that look like? Include profile open GoPro. Okay, so what we've said is that for stream boxes, we want OpenGoPro installed. Very easy. Okay, so now we have 3 new changes that we want to commit. Let's go ahead and add all of these for committing, and we're going to give this a nice message. We're going to say install OpenGoPro to virtual env on stream boxes. Okay. There's my commit message. You can see down here we are committing to a feature branch, so we will not be clobbering production. Go ahead and commit, save all, and publish the branch. So at this point, your Puppet code deployment process may look a little different from mine. In my lab environment, I need to log into the Puppet server and run Puppet code deploy, then the branch name, which is feature streaming -- wait. And there, within a few seconds, our branch is deployed to the Puppet server, and we're able to use it and assign it to our nodes in the Puppet Enterprise console. So let's go there now and assign our new role to this node here. I'm going to go into my node groups. I already have a hierarchy for my roles, but there's no role group in here or node group in here that represents my stream boxes yet. So let's go ahead and do that. Let me add a new group, and it's going to be under our roles parent. We're going to call this stream boxes. And for now, we're going to have it point at our stream boxes environment that corresponds to the branch that we just created. But we don't see that here just yet, so I'm going to leave that at production from now and click add. And I can click into this convenience link to jump right into this node group configuration. And here is where I have an opportunity to assign my node to this group. And just to keep this simple, I'm going to pin it by name. The name of this is Stream Pro to represent my Rock Pro 64 single board computer. It's a Stream Pro. I'm going to pin this node and commit my change. Now I'll head over to the classes tab, and this is where I can declare my role class. And so I'm going to start typing role : and I don't see my Streambox role class here. And that makes sense because this environment group is currently configured to look at our production environment, and our code currently exists only on a feature branch. So I need to change the environment that this node group is looking at. But before I do that, I'm going to click this refresh button down here so that our console has an up-to-date view of the available environments. Now that it says class definitions updated a few seconds ago, if I edit the node group metadata and change the environment, you can see my streaming branch now appears. I'll go ahead and commit this change so that now when I type role : you can see my Streambox class pops right up. Let's select that, add class. There are no parameters, and that's by design with role classes. So we'll just go ahead and commit. Very nice. So, shall we run Puppet on this? Let's do it. Head over and switch to my node here, SSH'd onto my Stream Pro node, and I'm going to run Puppet Agent. Puppet Agent --test --environment equals feature streaming. You'll say it'll show us using environment feature streaming. The agent is loading facts. And then we get a message here, local environment feature streaming doesn't match server specified environment production. Okay, so this is what we've hit here is, and our Puppet agent run failed because our role Streambox class is not in the production environment. So what we've encountered here is sort of a security feature of Puppet Enterprise that prevents you from accidentally running Puppet against non-production environments. We consider production to be the most safe, stable code there is, and so we need to tell Puppet that it's okay for this node to use feature branch environments. So I'm going to head back to my node groups, and there is this special node group down here called development environment. This comes with Puppet Enterprise out of the box. As long as my node exists in the development environment, it is allowed to use feature branch environment. So I'm going to pin my Stream Pro node to this node group. I'll commit my change. And now, when I return to my node here, clear the screen, we're going to run Puppet Agent test one more time. This time, instead of directing us back to the production environment, the agent was able to download the compiled catalog for our feature streaming environment and apply the resources that we defined in that code, including our opt OpenGoPro virtual environment and the OpenGoPro package contained within. And if we list now our opt OpenGoPro directory, you can see we have other folders in there, including our bin directory, which has our GoPro commands. I can access those. Open GoPro bin. Maybe I want to take a photo with my GoPro. And it wants to run with root privileges. But as you see, it runs here. Let's see if there's a better one that I should run. The presets. Just want to get a help output there. There we go. Some help output that shows that, these commands are working. Then there's one other thing I like to do when I'm wrapping up a task like this, which is to just run Puppet one more time and confirm that it is idempotent. That means we should expect to see no changes occur in this Puppet run. Indeed, that's what we get. You also see that this run was much quicker than the first one. The other one took a minute to go through and install all of those packages and dependencies on this rather slow single board computer, and now it ran in just a few. All right, that's it. Pretty cool. So if you'd like to see more demo content like this, please like and subscribe. And if you want to see a demo on a specific topic, leave us a comment down below. Thanks for watching, and see you next time.